Nama saya Bos Kanapati, Anala lagi Velu, number matrix saya B 00321104118. Today I am going to explain one of the OSI model. The first layer of OSI model is a physical layer. The lowest layer of the OSI model is concerned with the electrically optically transmitting raw unstructured data bytes across the network from the physical layer of the sending device to the physical layer of the receiving device. It can include specifications such as the voltage, pin layout, cabling, and radio frequencies. At the physical layer, one might find physical resources such as a network hub, cabling, repeater, network adapter, or modems. Function of a physical layer. Line configuration defines the way how two or more devices can be connected physically. Data transmission is a device defines the transmission mode, whether it's a simplex, half duplex, or full duplex mode between the two devices on the network. The topology defines the way how the network devices are arranged. Signals determine the types of the signal used for transmitting the information. Based on the scenario, the physical layer from the PC to UTM server transfer data bytes from the PC to a router and switch. Then the data bytes converted to signal. The byte stream grouped into code words or symbol are converted to a physical signal that is transmitted over the transmission medium. The physical layer consists of the electronic circuit transmission technology of a network. Now the second OSI layer is a data link layer. At the data link layer, directly connected nodes are used to perform node-to-node data transfer where the data is packaged into frames. The data link layer also correct error that may have occurred at the physical layer. The data link layer encompasses two sublayers of its own. The first, media access control MAC, provides flow control and multiplexing for devices transmission over a network. The second, the logical link control LLC, provides flow and error control over the physical medium as well as identified line protocols. This layer is responsible for error-free transfer of data frames. It defines the format of the data on the network. It provides a reliable and efficient communication between the two or more devices. It is mainly responsible for unique identification for each device that resides on a local network. It contains two sublayers, logical link control layer and the media access control layer. The function of the data link layer is a framing, physical addressing, flow control, error control, and based on the scenario, the data link layer adds the layer header trailer to the frame. The header which is added to the frame contains the hardware destination and the source addresses. For the UTM portal have a MAC address and the IP address, and the destination is supposed to travel in the flow control from the UTM personal PC to the data flow, maintain certain constants, does not get the data corrupted. Now we are in the fifth layer. The session layer is the fifth layer in the open system interconnection OSI model. This layer allows the user to on different machines to establish active communication session between them. It is responsible for establishing, maintaining, synchronizing, and terminating session between the end user application. In the session layer, streams of data are received and further marked, which is the resynchronized properly so that the end of the message are not cut initially and further data losses is avoided. This layer basically establish a connection between the session entities. The layer handles manipulates data and that receives a session layer as well as a presentation layer. Following are some of the functions that are performed by the session layer, and in this session layer, based on the project scenario, session layer works as a dialog controller through which allows streams to communicate in either half duplex mode or the full duplex mode of communication. In UTM, they are using the full duplex mode of the communication. And now we are in the sixth layer of the OSI model. is a presentation layer. Presentation layer is the sixth layer in the open system interconnection OSI model. This layer is also known as a translation layer, as this layer serves as a data translator for the network. The data which is the layer receives from the application layer is extracted and manipulated here as the required format to transmit over the network. The main responsibility of this layer is to provide or define the data format and encryption. The presentation layer is also called as a syntax layer, since it is responsible for maintaining the proper syntax of the data which is either received or transmitting to other layer. These are the functions of the presentation layer. Presentation layer format encrypts data to the send across the network. And finally, this the based on the scenario presentation layer based on the project scenario. The presentation layer in the sixth layer of the OSI model, which encrypts the data and send to the application layer for the end user. Using this layer, the end of the user is able to get understandable data output for the system.
Hi everyone, I'm Rashmika Kadiravan. Today I'm going to present two layers from OSI model. And the first layer that I'm going to present is transport layer. Transport layer is the fourth layer of OSI model, and it has three following functionalities. And as for the first one is segmentation. Segmentation is a process where a data stream breaks into smaller pieces before transmission, and each pieces is known as a segment, and the process of breaking data into smaller pieces is known as segmentation. On receiving a computer, it joins all the segments back into data stream so that the upper layers receive data in the format in which it was sent. And as for the second functionality is data transportation. And this layer establishes a logical connection between sending system and receiving system, and uses that connection to provide end-to-end data transportation. And for data transportation, it mainly uses two protocols, which is TCP and UDP. And as for TCP protocol is used for reliable data transportation, and TCP is a connection-oriented protocol. And as for UDP, protocol is used for unreliable data transportation, and UDP is a connectionless protocol. Main difference between a connectionless and a connection-oriented protocol is that a connection-oriented protocol provides reliable data delivery for reliable data delivery, and it uses several mechanisms such as three-way handshake processes, acknowledgement sequencing, and flow-through control. And as for the last functionality is multiplexing, and multiplexing uses port numbers. That this layer also provides connection multiplexing, which means it allows multiple applications to send and receive data simultaneously. And as for the second layer that I'm going to present is network layer. Network layer is the third layer of OSI model, and this layer takes data segments from transport layer and adds logical address to it. A logical address has two components, which is network partition and host partition. Network partition is used to group networking components together, while host partition is used to uniquely identify a system on a network. Logical address is also known as IP address, and once logical address and other related informations are added into segments, it becomes packet. And this layer decides whether the packet is intended for a local system or remote system. It also specifies the standards and protocols which are used to move the data packets across the network. And to move data packets between two different networks, a system known as a router is used. And router uses logical address to take routing decisions. And routing is a process of forwarding data packets into a destination. And that's all from me. Thank you.
My name is Nur Anisha binti Setibudi, matric no B03211047. So I will discuss about TCP IP configurations. So what is TCP IP? So the TCP IP is Transmission Control Protocol, Internet Protocol. So TCP is set of communication that are used to link network device on the internet. In a private computer network, TCP also use a combination protocol. So TCP refer to full IP suite which include a set of rule and process. TCP IP are the two most used protocol. Although the suite also include others. So TCP configuration in manual. Okay, in this section, you have to correctly identify the IP address for the Ulan system server. Therefore, you must produce a manual on how to configure IP address on the server. So the explanation should be support with the screenshot, appropriate explanation. So this is how to set up networking on the Ulan system server. I will show step by step to how configure the network. So the step one is click on start the search control panel and click to open it. So this is the example. So the step two is after that, click on network and internet section to view the network status. So step three is click on network and internet and then go click to network and sharing center. So for more detail, here is set up for configuration network for connection. Step 4 is network sharing center and then click change adapter setting. On the left side, click on the change adapter setting. All network will display there. So this is the figure network sharing and center section. Okay, step 5, you must go click to current Wi-Fi and then double click Wi-Fi and click properties. So the currently active network adapter, example is kediaman underscore pelajar, select the network adapter by double clicking. So the status network adapter will display the IPv4 and IPv6 connectivities as well as the speed are all visible. To begin assigning a static IP address to this host, click properties. Right click properties and then this is the example kediaman pelajar Wi-Fi network connection. So this is the figure of Wi-Fi status. And then click properties, double click Internet Protocol version 4, TCP IPv4. So after selecting properties, the properties of the network adapter will be shown. Double click on Internet Protocol IPv4 for setup and require configuration the host IPv4 address. So this is the example for clicking the IPv4. Step 6 is configure manually. So IP address and then click to subnet mask and then default gateway and then DNS server. So use the following IP address if you want manually configure IP address. We will set the subnet mask default gateway DNS. For this purpose, we use IP address 52187.244 for the subnet. The subnet IP address is from 52187.2441 until 52187.244.254. So this is how we configure the IP address, subnet mask, default gateway, and DNS server. So additional step, we use step up setup IP address 8888 alternate DNS server for Google Backup DNS. Step 7 is the final step. So open command prompt cmd and type ipconfig /all to check the configuration, and open command prompt, enter ipconfig, and here we can see the IP address, version 4 address, subnet mask, default gateway, DNS server have changed. So that's all. Thank you.
Hi everyone. So my name is Vimal Raj. So in this part, I'm gonna talk about the subnet calculation. So the subnet calculation, uh, we use 8 faculties to calculate the subnet calculation, and this is the network model that we designed for the 8 faculties. And the next is how we calculate the subnet for the 8 faculties. So you can consider 8 faculty. There are 8 subnets for the user. So and this is the class B address type, and in this scenario the faculty nearly about 500 to 1000 users, and we using FLSM subnet mask. And for for one faculty 64 subnet, for one faculty nearly 1024 can access the portal. So let's go to the subnet calculating. There are 6 steps in this calculation, and the IP address we start with is 172.2.0.0.0.0. So first step is to define subnet to be borrowed. So subnet borrow is 6 bit, and the subnet is 6 and the host is 10. And the second is find the number of subnet needed. Number of subnet is 2, calculated through number of subnet is 2n. So n is the number of bits borrowed. So if we 2 by 6, it would be 64. That is the number of subnets we have. And third step is to find the number of subnet masks. So to find the subnet masks, since we have 6 bit for subnet, so we needed plus 1 28 bits and 64 32 16 8 and 4 and get 252 subnet mask. And the total subnet mask is 255 255 252 and 0. And fourth step is to find the total number of hosts. The number of hosts is 2h. H is the number of hosts on the subnet, which is 10, and the total number of hosts is 1024. And the fifth step is find the number of usable hosts, and the number of usable hosts are 1022. So the last step is to prepare the addressing table. For our subnet, there are like 64 subnets. So these are the subnet and the network address, first address, last address, and the broadcast address for each of the subnet. And that's all from us. Thank you.